This video is a test review for our unit on triangles. Question number 1 asks us to find the missing angle measure here. We know two angle measures. This is a right angle, 90 degrees. This one is 50 degrees. I have to find the missing angle measure. Triangles always add up to 180 degrees if you add all three interior angles. The sum of the three interior angles on any triangle is 180 degrees. So one thing you can do is add all three angles together, set them equal to 180, and solve your equation. Combine like terms, isolate the variable, and you get your answer. The answer is 40. A shorter way, if you'd like, is to take 180, put it in your calculator, and subtract the two angles you're given. So 180 minus 90 minus 50 equals, and you'll also get 40. We also need to be able to classify triangles. This triangle has a right angle, so that makes it a right triangle. This triangle has four different angle measures. That means I'm going to get four different side measurements. So that makes it scalene. This is a right scalene triangle. Let's review classifying triangles. If you have all acute angles, which are angles less than 90 degrees, you have an acute triangle. If you have one obtuse angle, which is an angle greater than 90 degrees, you have an obtuse triangle. And if you have one right angle, which is 90 degrees exactly, you have a right triangle. Triangles can also be classified by their sides. Congruent sides are sides that have the same length. So let's look at some of those. A scalene triangle has no sides congruent, which also means you have no angles congruent. An isosceles triangle has two sides congruent, which means you have two angles congruent. And an equilateral triangle has all sides congruent, which means you have three congruent angles as well. All equilateral triangles are 60, 60, 60 triangles. Here you have an example of a triangle that has sides of 90, 50, 40. I'm sorry, angles of 90, 50, 40. If all angles are different, then all sides are different. That makes it scalene, and you have one right angle, so that makes this a right scalene triangle. This triangle tells us one angle is 90 degrees, one is 50, and the other, instead of just having an x, it has an expression, 4x plus 4. So I can't simply take 180 minus 90 minus 50 in my calculator. I have to use an equation. I have to add all three angles together and set them equal to 180. So I do that. Now, when I get ready to solve this equation, these parentheses end up being useless because I don't have a distributor. So I can ignore them and combine like terms. 90 plus 50 plus 4 is 144. When I get ready to isolate the variable, I first get rid of plus 144 by subtracting 144. To get rid of times 4, I divide by 4, and x is 9. The question on the test may say, find the value of x. If you do, we're done. The value of x is 9. The question could ask, what is the missing angle measure, or classify the triangle by its angles and by its sides? Well, if I want to know this missing angle measure, and I know that x equals 9, I just take that 9 and I plug it in for x. Instead of 4x plus 4, we have 4 times 9 plus 4, which gives us 40. So this missing angle measure is 40 degrees. Now I can classify it. I have a right angle, which makes it a right triangle. I have three different angles, 90, 50, and 40, which means I have three different sides. So this is a right scalene triangle. Now we're dealing with the exterior angle from a triangle. I know the three interior angles add together to give me 180, and I could use that to find x and know that this angle and this angle are supplementary. But there's a trick. When you're given these two opposite angles away from this exterior angle, the sum of these two opposite angles is going to equal this exterior angle. So x plus 68 is going to equal 124. And you can solve that equation. X plus 68 equals 124. Subtract 68 from both sides. This missing angle measure is 56. Or you can just take your calculator and say 124 minus 68 equals, and you're going to get your answer, which is 56, or 56 degrees. On number 4, we have another exterior angle. So we know that the two opposite angles, if you add them together, it's going to equal this exterior angle. The sum of these two opposite side angles will equal this exterior angle. So 55 plus 50 will give you the value of x. 55 plus 50 is 105. This exterior angle is going to be congruent to the sum of these two opposite angles. 55 plus 50 equals 105, so x equals 105. And to take it a step further, now that I know this is 105, these two are supplementary. I could say 180 minus 105 equals and get 75 here. And 75 plus 55 plus 50 does in fact equal 180. The Pythagorean theorem is an important concept in triangles. Let's talk about the Pythagorean theorem. It only works on right triangles, meaning it has one right angle. If you have a right triangle, then the two sides adjacent to that right angle are the legs, and the side across from that right angle is the hypotenuse. The Pythagorean theorem is a squared plus b squared equals c squared. A and b are always the legs, and c is always the hypotenuse. The hypotenuse is always the longest side of the triangle, but it's shorter than the sum of the legs. I'll say that again. The hypotenuse is always the longest side of a right triangle, but it's always shorter than the sum of the two legs. Here's an example of the Pythagorean theorem. We have a right triangle. We're given the two legs, 8 and 15. So we plug 8 and 15 in for A and B, and we're finding the hypotenuse C. From here, we just follow order of operations. Square the 8, get 64. Square the 15, get 225. Add, get 289. And to get rid of this square, you take the square root of it to get C. Whatever you do to one side, you do to the other. And the square root of 289 is 17. So the length of this hypotenuse is 17 millimeters. Let's do one more. This time we have a right triangle and we're given one of the legs and the hypotenuse. We're finding the missing leg. We're still using the Pythagorean theorem, a squared plus b squared equals c squared. We know one of the legs, so we plug it in for either a or b. It doesn't matter which one. And we plug the hypotenuse in for c. Now I put x squared here. I could put a squared or b squared. It really doesn't matter. And I solved this equation for x. So first, we square everything. 8 squared is 64. 9 squared is 81. On my way to isolating this variable, I first subtract 64 from both sides. Then, to get rid of this square, I take the square root of both sides. And the square root of 17, rounded to the nearest 1,000th, is about 4.123. And that is your review for the test on triangles. Thank you.